Now there are two methods of clustering. First is k-means algorithm. It is the most common approach. And then second is hierarchical clustering. So let's start with k-means algorithm. Here the first step is to randomly initialize k clusters having centroid as mu1, mu2 up to μk. As you can see here, we have randomly initiated the centroids, marked here with cross. Now assign a cluster to each training example xi, that is the row of the feature vector for each observation. Here you can see we have used I as superscript in x. This simply means ith feature. Now how do we assign the observations to the clusters? So we measure the distance of each point from the centroids. Let's say we have two centroids as shown in the figure with orange and green cross. And we have 2 points shown with orange and green dots. Then we will measure the distance of these 2 points from centroid 1, say orange cross. After that, we will measure the distance from the second centroid, that is the green cross. Now this is called Euclidean distance, and it is given by the formula shown here. So based on the minimum distance of a point from the centroid, we will assign that point to that particular cluster. As you know, there are different distance measures, but here we are using Euclidean distance. Now in the next step, we will move all the centroids mu1, mu2 up to μk to the average mean of all the training data points assigned to that cluster centroid, and then repeat step A and B until no further updates in the centroid is observed. That is how we assign the clusters. Now let's understand this with the help of an example. So in the first step, we initiated 2 centroids. Then we measured the distance of each observation and assigned clusters based on the minimum Euclidean distance. Now as you can see in the first figure, we have all the points in blue color. But in figure 2, we have few points in orange color and few in green color. This shows that they have been assigned into orange cluster or green cluster. After that, we will shift the centroid such that it will be the mean of all the training observations present in the respective cluster. Which means orange cluster will have centroid that will be the mean of its observation in orange cluster. And similarly, green cluster will have a centroid which is the mean of the observation in green cluster. Now we will again measure the Euclidean distance and shift the centroids. We will continue this step until no further updates in the centroid is observed. So you can see in figure 5 and figure 6, there is no update in centroid of the cluster. Hence these will be the final clusters. Anyways, you don't have to remember all these things. All these things will be done by R. I am just explaining you to make you understand the concept. Now let's move on to the next topic. As usual, for guiding the algorithm, we use a cost function. The function given below is called as distortion function, and the algorithm converges when the below function is minimal. This is also called within cluster variation or sum of squared distance. It is nothing but the square of the distance from each point to its centroid within a particular cluster, as we saw earlier in the figures. Now total within cluster variation is given by the below formula, and this is called as goodness of fit. Means we will have to minimize it to get the best model. Now to get the best model, we not only have to minimize the within cluster variation of one cluster, but for all the clusters. Then only we will get the best model. Hence we use total within cluster variation. Now moving to the next part. So the next question is how many clusters we should have. Well, there is no direct answer for this. We can select the number of clusters based on some pre-belief, based on our experience of the trade, etc. However, there are two common approaches that we use for this purpose. The first approach is the elbow method. Here we plot distortion, which is our cost function, against the number of clusters. And wherever it forms the elbow, as shown here on the screen, we can use it as the cut point and consider number of clusters corresponding to it. That is how elbow method works. Then the other method is the downstream metric method. In this method, we associate some performance metrics such as sales, revenue, efficacy, etc. with the chosen number of clusters. And then our aim is to get the optimized metric. For example, a t-shirt manufacturer wants to decide that how many different size types he should produce. So what he can do for the first instance, he can produce 3 shirt types: small, medium, large. So we will have 3 clusters. But then we have to think from the customer's point of view and see if the revenues will be more if they have, say, 5 t-shirt sizes to choose from instead of 3. So basically the downstream metric will be your yardstick in deciding the number of clusters. It could come from your past experience, your knowledge of trade, etc. So that is how you select the number of clusters. Our next method is hierarchical clustering.